Hi everyone, Mike's back here and Bryant Ficek, and today we're going to be talking about traffic simulation software and some study we've done trying to benchmark calibrating software against what happens in the real world. I'd start out with, we're both PEs and PTOEs based here in Minnesota. I have 3 different companies, a traffic study company, data collection company, and an online store where we sell hardware and software. And I also blog at Mike on Traffic. I did the data collection component with this. Bryant over here works for a well-established architecture engineering firm, TKDA. They've been in business for more than 100 years now in St. Paul. And Bryant is their lead traffic engineer, and he's the brains behind the operation. He does a lot more of the simulation, actually getting into the nitty-gritty of the software. He's worked on a lot of interesting projects around here. You've probably, unfortunately, heard our I-35W bridge collapsed a few years ago. Bryant worked on that project, rebuilding the bridge. He designed our first diverging diamond interchange, did all the analysis on that. I designed a lot of roundabouts, a big project taking away at-grade interchanges and replacing system interchanges and roundabouts and Interstate 494 and Highway 169. So Bryant's the brains here.
I think you did a better job than I could. So thanks, Mike.
And we've also, we're going to be launching next month, we've put together a book, a manual on how to do traffic studies. It is not a textbook. It is our guide on how we do traffic impact studies, lessons learned, and things like that. It's the book we wish we had when we started our careers. If you have any interest in that, email me, mspac@spacconsulting.com. So now to get into the real heart of what we'll be talking about, there's actually a group of us traffic engineers that get together and socialize, and this conversation basically started a couple years ago of, okay, we're working out in an area that's underdeveloped, underutilized, and we do a big study, and we throw in lots of redevelopment, and we come up and we say, okay, that little area is going to turn into something that needs a multi-lane roundabout, or it needs big intersections with dual left turn lanes and traffic signals, and we are saying we need big improvements to accommodate this growth. But how do we actually know that the software we're using, the results we're getting, are predicting accurately? We all learned in school when you build a model, you should calibrate it to make sure you're getting reasonable results, and some of us do that some of the time. We'll go out and we'll measure delays, or we'll measure queues, and we kind of eyeball the micro simulations that we're running to make sure it looks reasonable. But when we're going from an intersection that looks like this to this, driver behavior is going to change, headways are going to change, just everything related to it is going to change. So how can we calibrate our existing models to this and then take the giant leap and say those same exact behaviors are going to operate in this new intersection? So really we're wondering, as we're drinking beer there, are the results we're getting coming close to matching the reality? And so we started poking around, and there just isn't that much academic research out there showing what models are best, exactly what are the best practices. There seems to be a lot of regional variation on what people like to do. Some regions are better than others at giving you regional peak hour factors and saturation flow rates and some of the other parameters. But we're really interested in finding out what models can we get that actually, with just taking them out of the box and using the defaults, can any of them really come up to reality? And so we went out and my guys with me at Traffic Data Inc., we went to a bunch of intersections around our office. We went to an all-way stop sign intersection. We went to roundabout, bigger traffic signal intersection, another roundabout, another signal. We collected turning movement counts. We set up video cameras on all the legs of the intersection, so we did queuing and delay studies on the peak hours. So we got really the fine-grained data per lane of how these intersections are operating. And this was a significant effort. Just at a handful of intersections, we spent 76 hours behind computers with count boards doing data reduction, and that doesn't count the field time of setting up all of these cameras. So technician time, we kind of have about 100 hours into this, and Bryant says on the modeling end, he has about 100 hours in, and he's going to talk through what he did to kind of take our existing conditions data that we collected, which I should tell you is not an easy thing to do. It's really time intensive, and having video cameras on the ground, which is a step better than having bodies on the ground doing it. But even video cameras, your sight lines are limited, and there's some guesswork involved.
Yeah, and you can see what Mike's talking about back at these slides. These are all pictures from his videos as we recorded the intersections. So we had multiple cameras set up on each approach, trying to capture not only what was happening at the intersection, but making sure we got data from the field that went back to however far the queue went, so we could count the cars, make sure we really knew what was going on in each of the intersections that we looked at.
And having that benchmark data.
So then turning to the software side of things, at the bottom of the screen there, you can see which software we looked at. And so the reasons, I know there's a whole host out there. This only captures a small portion of software available, but we started with these because these are the primary ones that we use in our region. The highway capacity software, obviously, that's kind of the starting point for all of them, or most of them. They use that as their benchmark, the one that they use and then interpret different ways to get to the models. Rodel, obviously specific for roundabouts. That one developed in England to start, but again, we use that here to analyze single lane mostly, but individual roundabouts and more isolated roundabouts. So that's a primary one that we use here for that. Synchro and SimTraffic, those are also standards here. We use those for traditional intersections, more signals, always stops. And then finally getting to Vissim, that's the one that is now being used really only the last, 4 or 5 years we started using that?
Yeah, since we started getting more into roundabouts.
Yeah.
Everyone saw that as the gold standard when you're simulating roundabouts.
So yeah, the Vissim is used more in a corridor capacity. If you have an isolated roundabout, we would still probably use Rodel, but if we have a nearby signal or other intersections or series of roundabouts, that's when we would turn to Vissim. And so kind of looking under the hood, like the picture suggests, like Mike mentioned earlier, as we started with all these softwares and we started looking at all the factors, each of them has different ways to adjust and different ways to customize it and calibrate it. That's where we really tried to take that step back and say, should we be doing that? And can the software work on its own without calibration? Can we just essentially pull the software out of the box, put in our numbers, and go? And so that's the way we started to look at it. It was really not trying to mess with any of the inputs, not trying to do any of our individual customization. That I know everybody does some of that, but really just taking default values, taking default measurements, and then putting in the volumes to see what happens. So along those lines, obviously there were some changes that we had to do. For the roundabouts, you obviously have different sizes. We fell back on our own MnDOT standards. They have different criteria that they put in. They say these are the general ones you should try to meet, you should try to design to. So we used, again, default values, not trying to customize it to anything. Same thing with the signal timing. MnDOT here has a big manual that they use, and here's how you should set up the signal timing and how it should generally operate. So we tried to use those factors. Again, trying to think to that end product of if we're going from a little two-lane side street stop intersection to a multi-lane signal, we don't know what that timing would be, so all we would have are these factors to base ourselves on. So that's, again, just trying to get back to where we started and how we set the software up. So diving into some of the results. This first graph, we've got average delay, just your typical measurement. And you can see on the bottom here, we looked at 10 intersections, a couple all-way stops, some multi-lane signals, single-lane roundabouts, and then multi-lane roundabouts. So the blue line there at the bottom, and hopefully you can all see this well, that shows the field results. When we went out there and measured the delay from each approach, the overall, this is the overall average delay for the intersection, came out at that blue line there.
And I should interject here too that level of service E and F are considered unacceptable here in our region. So when we're designing long-term stuff, it's very much the standard to get to level of service D or better. We did have some debate whether we should be trying to find intersections that are E and F or even oversaturated. One, the data collection in the field becomes nearly impossible, especially queuing back through multiple intersections. And when we get to kind of going from the sleepy side street stop intersection to putting in the multi-lane roundabout, I guess our feeling is that when we're doing a design like that, we're not designing the roundabout to be at level of service E or F. Mm-hmm. So that's how we talked ourselves into it being okay that we were analyzing kind of in the level of service A to C range. Of course, more intersections could be added onto this graph. But that's our starting point and why we just didn't jump to all oversaturated intersections. And frankly, we don't have a poorly operating roundabout here within our region. They're all operating with very little delay.
So with these results, you can see generally, in all these different points, we tried to separate them out, if you can see them well, by the software we used for each of them. So you can kind of see how they compare back to the field results. You can see, like for instance, the blue dot here is SimTraffic. You can kind of see as we follow along, it goes pretty close to the field results. Same thing with Vissim. Most of them are within a pretty decent range. We did have a few outliers. Synchro, in particular, just looking at the Synchro results, was way off on the signal. So that was a little bit of a surprise there. But in general, we kind of looked at that and said, they're not doing too bad. They're matching it pretty well. Another way we decided to look at this, going back from average delay, looking at level of service, kind of a standard we all look at. And as Mike mentioned, for us, level of service D is typically acceptable. If we can get to level of service D or better, then that's what we would like to have at our intersections. So from the field results, you can see most of the intersections we looked at, level of service A, particularly the roundabouts were all there, and then we had a couple B and C for the all-way stop and the signal. And we've got each one labeled here based on where it came in. So again, for this first all-way stop, you can see it's at level of service A. SimTraffic matched that. The other ones came in at level of service C. So that default, that out of the box, just putting that in, still would have been acceptable, but it would have given us a level of service grade 2 worse than what was actually happening. And then just kind of following it along, you get a little better results as you move into the signal. SimTraffic and Vissim matching up at that level of service C. And then most of them did pretty well in terms of level of service on the roundabouts. little bit of a surprise that Rodel came out higher on some of the single lanes. That one, because it's been my experience in past projects, Rodel has been a little bit more rosy, a little bit more towards the level of service A, so I was kind of surprised when this came back, but again, this is that out-of-the-box default value. This is where it left us. So I have no doubt that if you come back in and try to customize, try to calibrate, so to speak, the Rodel, you probably get some tighter results and they might match better. I guess another thing to pull out of this one too, just from the highway capacity software, HCM 2010, for the most part it came out conservative, at least 1 or 2 grades higher than what was actually happening in the field. The exception was a couple of the signals that we had. Again, it was just underneath. But then just looking at that, we were looking at those results and just saying that's kind of a surprise that it was that far off based on that comparison to the field. So another comparison that we made was looking at the 95th percentile Qs. So again, this is the same type of marks here. That blue line gets to our field measurements for each intersection. We did measure all the Qs all the way around. What we're showing here is the maximum Q for any approach. We just looked and said, okay, for all 4 approaches, which one has the highest 95th percentile Q? And then we compared that back to what the software said. So this is where, looking at this, just you get some wild results. Sometimes we're above. You see a lot of those dots above the line. Sometimes signals always stop. You can see we're below there. So again, we get just some wild results. And as we were thinking about that and trying to come to some conclusion or some grips onto why it might be so different, really as we looked at the signals, you can kind of see how dependent that might be on signal timing. So really, as we looked at our signal timing, that's one area where it's very important, obviously. As you go back into that signal timing, yeah, you can use the defaults, but I'm sure in the field, obviously, it's been customized. They're very much trying to meet what's out there. So a little different than the defaults, and it shows up in the models. As we looked at the roundabouts, and this one we dove into a little deeper as well, and some of these, for the single lane roundabouts, we did overlap. So we looked at the same intersection a couple different times, and it was amazing how it varied. So if you look at these two, the single lane roundabout number 1, single lane roundabout number 2, you can see there was not a lot, but a couple vehicle difference in that 95th percentile Q, even though it's the same intersection. So just in the variation, the small variation on the volumes from one day to the next, we are finding differences in the field. And then if you can imagine that further for a roundabout, it really is going to depend on the type of driver you get. So as you get somebody new to a roundabout who doesn't know what they're doing, they may not have to stop, but they may stop on the entrance, and then they back up 4 vehicles behind them, and now you've got a longer queue, and it could affect the results. But as I said, it's just interesting to note the difference in how wildly different that can be as you go from roundabout to roundabout.
And I think we should point out, Bryant, that we did at the all-way stop intersection. This is the same intersection 2 different days. The signal, same intersection 2 different, or at that roundabout, same intersection 2 different days?
Yeah, the roundabout was the same 2 different days. Signal 2 and 3 was the same intersection 2 different days.
So you can see kind of differences in the queuing day-to-day, but to go back, the actual delay was pretty consistent. Delay there and there. Average delay is very similar day-to-day. Same with the signals day-to-day. The delay numbers are consistent, but the queuing numbers seem to vary more, and that's perfect. I think that's what you'd expect, since that queue is so dependent on who is showing up at the exact same time at the intersection, where that gets leveled out over the course of the hour.
So to look at this another way, too, for the 95th percentile queues, this first graph, we just put it at, that blue line's at 0, so if we said if the field measurement is 0, how many vehicles off are the results? And so you can see we're above and below, we're all over the place depending on which intersection you're looking at. And it's kind of a question of what's acceptable. You know, I don't know that we have an answer for that, but how far off is really acceptable based on the results? You can see some of the Vissim results, we're only 1 or 2 vehicles off from the field. That seems pretty good to me. But you get to some of the other ones, and they're 5 vehicles off, or they're 10 vehicles off, and it's trying to get a gauge on that. So this, again, this one just mainly shows you just that variation for the intersections we looked at.
And as a user, it'd be nice to know if, okay, this one is always a little bit more conservative or a little less conservative. Right? But it's more disconcerting when it's falling both sides of that line. Yep. That sometimes it's over-reporting and sometimes it's under-reporting.
Mm-hmm. A third graph, just again, we're looking at the same thing, but trying to get to what's important or how much of that variation. This time we looked at percentage off. So if the field results came back at 4 and our model was telling us we had 8, and it's only a difference of 4 vehicles, 100 feet. You know, that may or may not be a big deal, but that's 100% off. And so as we looked at this, you can see for some of the software, you get some wild variations there. So I'm looking particularly at that first single lane roundabout where we're showing almost all of them are 800,000% off. I mean, you can see just that wild variation, and you start looking at that and going, now that could be a problem. And then coming back to, again, what we said about the day-to-day, where we looked at the same intersection over a couple different days, you know, the volumes only changed a little bit. They're roughly the same, but from the single lane number 1 to single lane number 2, you can see a big drop in the model. And just that kind of wild variation when essentially we're looking at the same intersection. All right, so that's all the data that we were looking at, and so now we come to,
we should say we actually have a mountain of data, and that's actually a real issue in this, is how do you present it in kind of bite-sized pieces? How do you tease out? Should you be, I mean, if we did these charts per lane at all of these intersections, I mean, you could just start to visualize the 3 dimensions of data, and just how do you tease results out of that? But we've tried to come up with some kind of summary picture and kind of trying to draw some conclusions of which software is best, at least of the ones we use in our region. And as this picture shows, I don't think we're quite there yet. Right. We certainly would love a lot more data points, and we'd love more statistical analysis on the results, and also love verification on how we're doing things. Maybe other people would get different answers. One of the bigger hurdles we had was what is out of the box. So what are the default parameters in Vissim? Because they aren't very clear at telling you exactly what they are. I mean, HC, highway capacity manual, yeah, all of the defaults are spelled out for you, and you just plug those in.
Well, and that's where I give Oregon a little props here, because they have a very good manual. And that was actually something we referred back to, and something I tried to either take here in this region, or, you know, if we can use it and follow that, great, or at least maybe that's a starting point for us to try to come up with something similar of, this is how you use it coming out of the box. These are the things to look at. kind of coming back to our conclusions as we started getting into, really no software nailed it. You think back to those graphs, we had the dots all over the place. You could see they varied. Some were above, some were below. It was just a good variation. We didn't have any that really matched up really well or matched up consistently with the field results. Second one we kind of concluded is that the models are better at predicting delay than cues. As we go back to those graphs, the models didn't exactly nail it in terms of delay, but they were closer. They came up, in terms of level of service at least, they came up roughly close to the field results. So in terms of delay, in terms of that level of service, the models were better at doing that than the cues. We had more variation.
And so, yeah, the delay number is obviously averaged out over that whole peak hour, but with the maximum or 95th percentile cues, you're really looking at a spot event. And we picked 95th percentile cues because our region generally defaults. Lots of traffic engineers around here will go as far as designing turn lanes based on these 95th percentile results, where maybe the average cues are more spread out and a little more normalized, but we're trying to hone in. We're trying to dissect how we analyze things here in the Midwest, specifically here in Minnesota, and trying to find out if what we're doing is the best practice.
Right. So in this case, we looked at the highway capacity software, HCM 2010, and as we pointed out, it had generally conservative results. And why we put this conclusion here that the initial use might be sufficient is because generally that's a very easy software to use. You can just, there's not many inputs to it. You can just kind of put some stuff in and go with it. So it may be sufficient. You might be able to look at that and say, yeah, I know I'm conservative, but if it can work in HCS, then it should work with all of them.
Yeah, you're done.
So why do I need to take that extra step to do a simulation or something else? If I make it work in the worst case, again, why take that extra step? Why spend the extra money? This is kind of a personal one, but round your results. All the software tends to kick out delays, average delays, to the 10th of a second, and it's not close enough for that. I mean, we're not that specific, so I'd recommend everybody round your results. There's no reason you need to report it to the 10th of a second. It's absurd to think that we're that accurate.
No,
and especially when you start looking out into the future, like part of our thing here. If you're looking out in the future, if you're forecasting volumes, you've got enough error built into your forecast that 10th of a second is just ridiculous. And kind of our last one, experience matters, and this kind of ties into that regional calibration. But we did look at that, at least what we tried to consider was the default out of the box. No software nailed it, like we said. So this is where that experience matters, and going back to what inputs should be changed, what should be customized. And so as I kind of played around with the software a little bit more, I was able to get the results to match better. I was able to say, okay, I normally customize this feature, I normally customize this a little bit, and by doing that, I was able to tighten up the results. So this is where that experience does matter. The defaults don't give you the best results. You are able, or you should be able to use some of what you've gone to in the past and say, hey, this has worked for me. This helps bring the results closer in, and that's kind of exactly what we're finding here.
And I think there's a good point to bring up a book that Bryant and I are both fans of called The Signal and the Noise by Nate Silver. And in there he talks about all kinds of forecasting. He's famous because of his political forecasting, but he's worked in a lot of different arenas doing different forecasting. And a fascinating chapter in there on the National Weather Service and how their models have improved over the last 30 years, how they're taking advantage of computing power and how their models are becoming more fine-grained. But what the Weather Service does that we don't do as an industry is they go back every day and they try to look back at, okay, how close were our forecasts and why were they off? And an interesting thing that's come out of that mountain of data and themselves checking themselves constantly is they find that their models keep improving, but their human being weather forecasters who are looking at the models are adding value consistently. So the trend line of the models is getting better, but the trend line of the human beings being 10% more accurate is following that same trend line. And anecdotally, what some of the folks think is that the human beings get better at looking at the results. They run 5 different models and simulations on the weather and different software packages, and over time those experienced human beings find that, okay, for this kind of weather pattern, this software is a little bit better, and when I find this condition where these 2 models line up, that usually nails it. And so they add that value add that a computer can't pick out, and I think that comes into just we don't ever, well, at least here in our region, we don't go back and check our results. We don't go out and get saturation flow rates, and we don't get out and do queuing and data for the vast majority of our projects. We just take these models, chug away, take the results, and say we're done.
Everybody does their own little customization, own little calibration.
But it's based on gut reaction and kind of how the screen looks. It's not based on data. It's not even based on real-world observations of somebody having 40 hours of field observations. So that's what we're trying to bring, a more scientific, how can we learn so we can improve,
or at least get the conversation started. And then the last one on there, accurate results for long-term improvements are questionable at best. So the further out you look, the more things change, the more reason we have to question, is it really accurate? So, and this gets back to, again, a little bit of the practice in our area, and unfortunately we don't know if it's the same over on your side, but it's, as we look at things here, we're often asked to look 20 years into the future. So provide forecasts, provide analysis for 20 years in the future. And that's where, as we went through this, and really as we've been talking over the past couple of years, is that the right thing to do? Should we really be basing some of our decisions on 20-year forecast, 20-year analysis? So that's kind of a very big topic, but for this point in particular, it's just, as we looked at it, those accurate results are going to be question marks. Is it really providing the value that we think it is?
Yeah, when we can't even nail existing conditions,
right?
With these models, how much variation going forward is there going to be? So where do we go from here? Obviously, we're just kind of at the tip of the iceberg, and there's a long, windy road in front of us. So obviously, we just took the software out of the box, and Oregon, your region is better at having more standardized peak hour factors and saturation flow rates, where here in our region, everyone just takes the defaults. So obviously, that's a crucial next step, is to try to figure out if any of those factors, if we plug in more of our regional numbers, will those nudge the results closer to reality? There is a danger in over-calibrating. You can't, if you calibrate too tightly for a specific data point, but that data point's erroneous, you could really be pulling your trend line of all of your future stuff. So that's why we think coming up with regional factors, not intersection factors, not corridor factors, but just kind of, again, getting one step better at the defaults, that's important, and that's one of the big things we want to tackle next.
And then the next question is just how many of these factors should be adjusted? Is it just the saturation flow? Is it just looking at the speeds in your simulation? Is there a handful of factors that should be adjusted and then the rest can go to the default? And that, I think, is a key point. So you're not wasting your time trying to get everything exact when only doing a half dozen factors will get you 95% of the way there. So it's really a question of how much effort needs to be going into this calibration.
Yeah, how sensitive are the models to the different inputs?
Mm-hmm. So then this one, should more than one software be used on a project? This is where, thinking back to those results, we had wide variation, or we had some variation depending on which one you used. So should this be something, kind of goes back to one of our conclusions, should you start with HCM as your initial and then use a different software to back that up? Should you use SimTraffic and Vissim to compare the two? I know this in particular would extremely drive up the cost of some of your studies. I mean, using more than one is obviously can be overkill, but given the results here, and we know it's a small sample, but should that be something we look at? Maybe that should be something to say, hey, if we look at it two different ways, we know the results. If they agree, we know the results are going to be somewhat close. If there's a wide variation, maybe we need to look at it in a little more detail.
And lastly, this is as a guy who goes to his fair share of public hearings and talking in front of city councils and neighborhood meetings, the A to F gradation is parents, especially with little kids, you tell them their kids bringing home D's or E's, and you say that's acceptable, they'd say, I think not. So this A to F idea, I very much understand the historical concept of how we got here, but would we be better off, given the modeling variation, of dialing more into a pass-fail system? That is our modeling results even too fine-grained at a level of service A, B, C, D, E, F? It's clearly reporting even to the second of delay, average delay, is false precision. But that's one question for our industry of trying to get at how do we present information so that policymakers can make good decisions.
I think with that, that's what we've got for you. We're definitely here to entertain any questions and answer as best we can.
Yeah, we're hoping to get a conversation going, and Miranda going to open it back up to a two-way conversation.
Yeah, can you guys see the question box?
Yes.
Okay, if you guys just want to start going through that, and then our group here.
Oh, wait, well, I only see the...
All right, I'll read these to you. So the first one was, oh wait, you guys don't care about that one. With WisDOT going more towards Sidra from Rodel, and the top study recommended Sidra, why wasn't Sidra used? One could argue that Minnesota should be switching as well.
We agree, and we actually started dabbling with Sidra, and we don't use Sidra here in Minnesota, and we don't have much experience with it. So it would be great to find a Sidra expert and pull them in and have them run Sidra on our scenarios and add it to the matrix of what we found out.
Yeah, and there's other ones too that I think would be good to add, but this was just our regional experience, what we know best.
Yeah, this is our, hey, let's spend a couple of hours of our free time over the last couple of months because we have nothing better to do. What can we accomplish? So, yes, no, we realize there's lots of holes in this, but we're trying to start the conversation, and it would be great to set up a national database so everybody can start adding onto this. To try to use this as a platform to really spread out how we do this and to refine how we do things and find out, hey, if Sidra matched up the line and matched the field results, the whole industry should drop all the other tools and use Sidra, is what I'd say.
All right, another roundabout one. I don't know if this is a question so much as a statement, but I would argue that a multi-lane roundabout at level of service A could be over-designed.
I would agree. Yeah, I don't think there's much to say to that, but other than I agree.
Yeah.
It just happened to be, well, actually the one that we studied, it's interesting that one has now been changed to go back. They dialed back a couple of the lanes, so it's that was recognized by the agency as well. So
we got another roundabout one. It's from Howard. He's a big roundabout guy in New York, so he has a lot of good opinions about this. The use of HCM 2010 for roundabout leads to the possibility of over-designing roundabout, which leads to faster speeds and higher crash rates. This isn't much of an issue at signals, but critical at roundabout. Again, more of a statement than a question, but you guys can add on to that.
Well, and that's why we think it would be much better to get to a pass-fail scenario on this when we're trying to design alternatives and dial in where are the bright lines that it makes sense to put in a multi-lane roundabout. And that clearly is going to take more experience, but we also have to have all of our analysis tools help us make better decisions.
Yeah, I would agree with his general comment. I mean, that's some of the issues we've been having here in our roundabouts are because they've been overbuilt. They're trying to plan for 20-year volumes rather than just saying we know we can expand it in 10 years if we need it.
And that's actually a huge issue with roundabouts, in my opinion, is that a signal, you can always change the signal timing to, if you want to keep that main line going, you can do that. But once you build the roundabout, it is expensive and painful to make adjustments after the fact. And so you can build it, you can stripe out portions of it, you can try to do, there are ways to do it. I don't know if I'd necessarily agree with that full statement. I think there's ways to build them where you can plan for that expansion. Okay.
But you got to plan for it ahead of time.
Yeah.
And I think that's what we need to be doing more of, is saying, can we get by with a single lane and let people learn on it for 5 to 10 years and then add something on the outside or the inside, depending on how it's designed. But you got to think of that ahead of time.
And I think the knee-jerk reaction, at least in our region, is conservative engineers get out there and build it, and you better be certain it's going to work on day one because your reputation's on the line.
Well, and I think pulling it back to our presentation, too, I think they get a little bit entranced with the numbers, with the results, and saying, well, we may have an issue in 10 years, so we should build it now so we don't have to come back in 10 years. We can just build it and forget about it for 20 years. And for roundabouts in particular, I don't think that's the right answer.
Another kind of roundabout question, but I had the same question for signals. A couple people asked us, when testing with Vissim with roundabouts, how did you assign right-of-way, priority rules, or conflict areas, or did you test both? And then same thing with signals, did you use conflict points or priority rules?
Use priority rules. I've had too many issues with conflict areas, just some weird results that have happened based on previous experience. So for these results here, it's been using priority rules. For the roundabouts, at least. For the signals, it was more of a combination, depending on the signal timing. The conflict areas work well for the protected permissive lefts and that sort of thing. So they're much easier to use, and they seem sufficient to me in that case.
Do you have experience that you would say one is better than the other? And that certainly is a valid outcome of this kind of discussion, is there a best practice and one should be used over the other?
Yeah. I mean, this was based on my experience that the priority rules work best for roundabouts. But
I've been in this argument before, too. This is a good one. How many simulation runs were done for like SimTraffic and Vissim?
we did 5 runs for each and then took the average of those 5. And I know in the FHWA guidelines they have a way to figure out how many you should be doing. They have a process you can go through. But again, for this instance, we figured 5 seemed appropriate to give us, at least a starting point to look at that.
And for better or for worse, that's our default in Minnesota. I guess I don't. Yeah, all the studies I see, everyone says they ran 5 runs.
It's a nice round number.
Do you actually follow the FHWA guidelines and every time, or do you just pick a number like 5 or 10 and run that many?
Well, I wrote the Vissim protocol and we said 10, but it was a longer argument as far as following the FHWA guidelines. And we have somebody here who just presented on that from WashDOT. He's all for the equation, but hasn't used it on a project yet.
Yeah, that's the practicality, too, is getting out there and how much better is. I would love to see the study that took a lot of field data and compared the results of 5 runs versus 10 runs, or using the equation and seeing how it lined up with just using that as your variable of how does it line up with matching reality.
Now, one thing I did for the 5 runs is I did go back into the individual results for each run and tried to make sure that I didn't have any outliers, that if they were all at, say, 10 seconds of average delay, I wanted to make sure I didn't have one that was suddenly 30 that was pulling the rest of the results off. And so I was able to look at that and see that I had pretty consistent results through each of the 5. And so, again, that's why I figured it seems good enough for this exercise.
Yeah. This is a good one. I missed the first part of the presentation, but did you say whether your field measurements were collected on the same day as the data collection for the analysis?
Yes. Yes. So we used video that we collected the middle of the intersection, and then we had video of all of the approaches. So all video from the same days, and then we went in, we did a 2-hour peak hour turning movement count. From that, we got the peak 60 minutes, and based on that peak 60 minutes, then we watched each approach leg video for the 60 minutes to get the delay and queuing numbers.
All right, and then, people are still asking questions. Are the Synchro results, Howard actually asked, is he the only one asking questions, but there's more. Okay. Are the Synchro results from HCM 2010?
No, it's from, the Synchro is for Synchro, not HCM 2010. So we did the 2 different ones. They match closely, but it is from Synchro itself. Yep.
Do you have any theories, speculations as to why the delays for the multi-lane signals were so much higher than Synchro than with other software applications?
We think it's partially the optimizing. That's part of it, that if we would have run different optimizing instead of just taking default signal timing values, we probably would have come closer. That's clearly one issue. When doing this kind of analysis, should you be optimizing the signal timing as you're doing these kinds of analyses, or should you be just taking some reasonable default value and saying, we're going to live with this scenario?
Yeah, other than that, I don't know.
We were surprised.
That one, it might have just been an outlier that, I don't have a reason for it.
I have my thoughts. For the Vissim runs, did you also use the default vehicles, or did you do any customization? Like, did you do the American default or just Vissim standard?
Use the North American default for the vehicles.
And then this is kind of related to the Synchro question. Was it Synchro 7 or 8? Because in 8, you have the option of HCM 2010 and 2000. I think that was what the question was kind of referring to earlier.
It was from Synchro 8, but it was the Synchro results.
Oh, okay.
So, yeah, you have that option in that software to go to 2010. but we wanted to do the Synchro results as well.
Okay, so
they are a little different.
They're close, but they are a little different.
So we have a group here. I don't know if anybody has, I can read you a few. Howard added that I would recommend using priority rules even though PTV doesn't agree for roundabouts.
What's that based on?
I don't know. Howard's not in the room.
Okay. I mean, we have lots of people who have lots of opinions, but what we are trying to get at is what is field verified recommendations versus gut intuition.
I mean, I agree with Howard, and that's obviously what we used here, but that's just based on my own experience as opposed to trying to get back and measure the differences between the two.
Okay.
Yeah, and we have PTV in the room, Karen, who's a proponent of the conflict points. I actually went back and forth with her on this on the Vissim protocol, and I came to it's useful. Both of them are useful depending on the geometry, but kind of a gut thing. Does anybody?
I think they can. I think they can both be useful as well, but for roundabouts in particular, I've just been using priority rules.
Well, there's fundamental behavior behind each of them that's different. That's what we're trying to do.
Yeah.
Achieve the secondary part of driving behavior. And priority rules gives you absolute control over that gap acceptance. So, if you want to model that driver behavior through that conflict area for different types of different capabilities, or whether you want to have absolute complete control over what that gap is. So, we're talking about some people, a lot more people are using conflict areas now because they're looking for that variation in that smarter behavior where both people see the conflict area versus the priority rule that doesn't allow for that level of intelligence. So it does depend on geometry and some personal preferences.
Did you guys hear that, Mike?
Unfortunately, not at all. We knew Karen was talking, but it was too far away. We couldn't capture
I think Howard heard it because he said, hello, Karen. My impression of what I got from that was that conflict points are better in the thought that they actually replicate how vehicles are going to act when they're entering the roundabout, but sometimes geometry and just, software supplementations that sometimes the conflict points aren't going to work. But when you're using priority rules, it's not actually completely accurately modeling how the vehicle would operate as it enters there, because it doesn't look until it gets up. Yeah.
You're telling the model what to do rather than allowing the model to replicate what is reality.
Yeah. So we have a room full of people, and people have questions. So
maybe you could take the questions and then just repeat them back to make sure they show up on the YouTube video as well as make sure we can hear them.
Yeah.
Or have them
come up closer to the mic.
Was there any consideration of signal progression? It sounds like you guys didn't really do any optimization or anything.
No, and at this point, we treated these more as standalone intersections.
Yeah.
And that certainly is a whole other branch of how to analyze this and is one of the theoretical benefits of going to microsimulation. But hopefully, at least for the basic level stuff of, again, trying to get to taking a study and get a corridor to a passing grade, one would hope you would have decent progression through it as part of the analysis.
Does anybody else have any questions in there?
So just to clarify on the signal timing, did you optimize splits then?
What we did, not optimized per se, it was more using the MnDOT guidelines, setting up the min max based on the main line and side streets. So we had one that was clearly the main line. We devoted most of the time to that. We had protected left turns, which we divided some of the time to that. So we didn't come in and hit optimized signal timing, optimized splits, or anything like that for Synchro. It was more just based on, like I said, trying to get back to those defaults for MnDOT and saying, here's our min and max, and going with that.
Did you use the same signal timing in Vissim as Synchro?
Yes.
So I don't have a question, but just a thought on a rant that I always go on. So the queuing, that was really great for me to see because I definitely agree with the thought of a lot of people are using queuing to make alternative decisions and design decisions. Have you seen that on other projects other than this? And I don't know, do you have any more input on that I think this room would be interested in?
A lot of consultants will make design decisions based on queuing results, and typically from SimTraffic. And it really comes down to maybe you should just maximize what you can fit in, or you should go to a default 300-foot left turn lane, or designing a turn lane down to 10 or 20 feet based on these results sure seems erroneous.
Yeah, I guess my thought would be it should be used more as a guide. I think we should have a default, and we kind of do in this region. That 300 feet with a 180 taper is roughly what we used here, based on more on the slowdown speed from 55 mile an hour. Gives the person time to move over out of the through lane and slow down. But I think if we start with that, we can use the software to either reinforce it or say, you know what, it should be 100 feet longer or 200 feet longer. I would agree with Mike. We don't need to go to 322 feet or something like that, I would say.
And it is disconcerting that the models will give results both over-report and under-report. So that's certainly, again, huge caveat. We only looked at a handful of peak hours here. A lot more data collection and analysis should be done here, but I guess it sure raises the flag if somebody's telling you they're designing a turn lane down to 20 feet based on some simulation results of some type of forecasts.
Or even the reverse. You know, if they're trying to say they can get by with a 100-foot turn lane based on this, I mean, that might be a flag right there, too, to say maybe we should have it a little longer just because we don't trust the results.
Mm-hmm.
Real quick, Mike and Brian, thank you so much for your presentation. And I completely agree with your comments about a missing piece is going back and looking at what we've seen as outcomes of these studies. But getting back to this, I think the discussion that would be most productive for this group would be what pieces are necessary to move us from the default to a more accurate result.
Yes.
Because what you're comparing is a very precise data that's collected, and then you're kind of throwing it up against some default measures, and I think you're getting at apples and oranges a little bit. So, and especially you're hearing people talk about signal timing. That's such a fundamental capacity at intersections. Obviously, you guys have put the caveats on it, and every region does this differently, but you can't necessarily look at the defaults and say, well, why don't these work? Well,
no, and we're not trying to go there. What we're trying to say is if you're going to be changing the models to calibrate to something, those somethings should be well thought out, well documented as, okay, we change in this region to change these defaults to this value because that better matches reality in our region. So whatever that takes, I 100% agree that further study gets you there.
Yeah.
I am not a fan of saying you should optimize the cycle length down to 5 seconds and allow a 5-minute cycle length and do all kinds of crazy stuff to try to make it work.
Do you see people do that, though? I mean, here in our region, you get the actual signal timing. You look at it and calibrate at least the signal timing. So is that happening in your region?
Yeah. What if you don't have one to start with? Yeah. I mean, what do you use if you're going from an unsignalized to a signal?
Okay.
I actually I just reviewed the Florida APM, and they said, you know, if you don't have the signal timing, then here's some of the steps. And it was like, why wouldn't you just use the real signal timing? Seems very common to us here. Like you would never just put some optimized thing in there, but I think that it is being done in other locations.
But and I think the huge question, though, is if you go from a sleepy little backwater, unsignalized intersection, and you're going to drop in a big intersection with dual left turn lanes and protected phasing, you need to have some parameter around that for what is a reasonable signal timing plan.
Yeah. I mean, that's,
So just to follow up with Sean's comment there, so it is kind of an apples and oranges comparison looking at this really precise data set to the defaults, but also between software packages as well. So I think it's just important to note that depending on your application, understanding that there's fundamental differences between deterministic and simulation, and depending on the different elements that you have in your particular project, one package may be more appropriate than another. So I think it's difficult to put general trends of certain software packages are generally better for certain generic situations, say roundabouts or always stops. It really needs to look at the specific project. So are there dynamic conditions, rail crossings, paths, bikes, different elements that may not be captured with the deterministic analysis, and use that as more of a guideline of your software selection.
Sure, but if the microsimulation software is proved to never match up to reality, being able to put in more features likely will make it more accurate. So
But by definition,
I think I mostly professionally agree with you, but those parameters for deciding when to go to the microsimulation and how to use the microsimulation, we're still doing based on a lot of gut reaction and maybe even common sense, but we're not tying it back to documented experience, where that's what we're trying to get back at, this whole notion of the National Weather Service. They go back and they look at their models and they see how their predictions matched up with reality, so they can learn and they can keep getting better. And I think that's a key step that our industry misses.
I think it's two separate issues, because fundamentally a simulation model will never match unless you go through a calibration process, and that's regardless of whether it's Vissim, SimTraffic, ceramics, core sim, AIM-STAN. And then there's...
But how do you... But then it gets back to our scenario of you have this giant area that's undeveloped in a cornfield and you drop in the Mall of America. What on earth do you calibrate to?
Sure, but I think there's two different elements to that, right? There's the calibration, and should a model represent what's in the field right now, straight out of the box, but that's part of the calibration process. And the other part of the forecasting I totally agree with, but that's not necessarily a software-related issue either. That's also a forecasting issue. It's a trends issue. There's so much more to that piece, and I think it's a bigger issue or set of issues than what we can address through the work that was done for this presentation. But going back to the calibration,
we're not presenting this as the end-all, be-all. Certainly, this was a handful of intersections, a handful of software. I mean, like Mike started out talking about this. I mean, this was more us and some other people every now and then. I mean, just kicking around the idea of
how do we know that this model is going to represent a reality in the future? Even if we pin down the exact traffic counts that were happening, how do we pin down that this model represents that future?
And I think the bigger overall question that we're trying to raise, too, is just how do we make ourselves better as an industry?
Well, I think you brought
part of that is coming back and looking at stuff like this and saying, yeah, this is a first step. This is something to start a conversation. And then just where can we go from here? Can we keep doing this? Is there a way to set up some national database where we can keep piling in data and then eventually come back and make some more valid conclusions, some more final conclusions, I guess.
And hopefully make the actual software packages to be able to use those data sets to refine how they do things.
We have Ray from Washoe has a question.
Well, it's not really a question, more of a comment. We all kind of know that future conditions are unknown, and any volume forecasts that we do are likely going to be off. And so trying to say that this software is going to produce the accurate result 10 or 20 years out, we know it's going to be off. But what the software, I think, is more intended is for being able to compare different alternatives, and that's more what we need to focus on, is that comparison, not really saying this is what it's going to be.
Okay.
20 years out.
Okay, that's fair enough. But what if we find out that a software package does great with an always stop, fails miserably at roundabouts, and does okay at signals? How are you comparing the alternatives? And I guess that's just a question that dovetails very well. And I agree with your point that we're trying to get apples to apples so we can make educated decisions. But I have lots of people in this region that says, hey, Synchro SimTraffic is great for signals, but pretty darn bad at roundabouts. That's a very common theme for people here. Yeah.
I think you may be, I think you may be able to apply those trends on the deterministic packages, but on the simulation, again, it comes down to calibration, because I know for a fact that you can calibrate to pretty much any control type under the local conditions. It's just, the level of effort and the level of data that you put in, and, your regional, I guess, spin that you put on it. So I don't know, it just kind of comes down to the particular project.
I think one thing that we tried to do with the Vissim protocol was get as much of this out in the beginning, develop this project methods and assumptions, and I think that kind of helps you a lot. Not say, oh, well, we didn't know going into this that we were going to analyze a roundabout. You need to know that at the beginning and make sure that you set up your process and tools so that you're selecting the right tools or going through the process correctly.
Yep. I think we need more of that. Yeah.
I really appreciate the presentation. I thought it was an eye-opener. I'm most familiar with Synchro and SimTraffic, and I guess what strikes me is both of those overestimated the delay for all of the signalized intersections. Yet one of the things we are really focused on here in Oregon and mandated by ODOT is a lower saturation flow rate, which means that the predicted performance of the intersection is even worse than we have with the simulation. I mean, this is crazy. I mean, I don't know what we do about it, but I think we ought to just recognize that it's a model, it is a tool, and forget all of this refinement. I agree completely with the observation that we should use it as a comparative tool, not a success failure. And we decide we need a massive intersection improvement because the delay increases by a second. We're plus or minus 50%.
This is an Oregon thing. I don't know if you guys deal with that a lot in Minnesota.
No.
I actually just met with TPOW last week and kind of gave a presentation where I pushed them towards, because Synchro, anytime you start to get a little bit of congestion, starts to exponentially grow that. It's kind of a good way to put it, as you can kind of see in your results of maybe that is a good indicator of when you need to be going to simulation, and not just even if there's multiple modes, but can it even handle this congestion? Is it going to be starting to overestimate it with all the, beyond just the saturation flow rates, the driver behaviors that they have in traffic that are definitely push it even further, even worse. Let's see.
It's important the engineer understands the limitation of any deterministic.
Yeah. Somebody wants a copy of the field data. I said I'd provide your email. Let's see. I think Howard was doing something else with his typing. From a DOT perspective, I can put a number of hours to build a model, but have a difficult time giving hours for calibration, and then also determining how much return I get on the calibration effort. Good thought. FHWA collected data during NGSIM for the reason you mentioned. Funding is not available to continue this. To continue, this data is crucial for microsimulation. Defaults must be changed based on the field or similar field results.
And that was the point of that NGSIM effort, was that it was to see if these software packages could actually be adapted to match this field data. So it went back to the whole idea of you have to calibrate a model, and can each of the software packages actually be modified appropriately to reflect that calibration.
Sometimes I think it comes down to just look at it. I know, Ray, we were working on the roundabouts, and there was one where it was kind of a teardrop type situation. So it was free flow for 2 lanes and 1,600 vehicles with 600 vehicles trying to enter. And Synchro was showing that that would be a V, and Vissim was showing this is just going to crash. It was like, well, let's stop comparing the tools and let's just think about this logically, what makes sense.
Experience matters.
Yeah, and we compared HCM 2010, Synchro with different environmental factors, Vissim, and they were all different.
Miranda, what's your take on Synchro compared to these, based on what you've worked with?
I think Synchro is great for single lanes. I think it's pretty good for some dual lanes as long as you're not getting complicated at all. And if there's no intersections that are nearby, they kind of brought that up. Howard, my name's Miranda Wells from HDR. Once you start getting more complicated, like it doesn't understand the teardrop and that flow isn't going to be mitigated. It's going to keep going as a free flow movement. So
It's also quite optimistic depending on your driver behavior and multi-lane rail tops.
But you can change the environmental factor, and we did see that brought it a little bit closer. I think Howard actually, I read your thing where it was a 1.1 and 1.2 environmental factor, and that brought it quite a bit closer. I wish Howard could talk right now because he's like the national roundabout guy.
Mm-hmm.
Does anybody else have questions, thoughts? All right, this is all recorded. Randy's got one more question.
Hey, Mike, this is Randy McCord.
Hey, Randy.
Hey, I just wanted to make sure there was a lot of good things brought up today, and we have a district meeting at ITE coming up in Rapid City.
We do.
Session. I knew you'd laugh, Mike. We can build sessions around this, and topics that sounded pretty mundane, but whether we should be using 20-year forecasts for simulation and forecast, default versus detailed factors, and when to use both, progression and how that's done from HCM to Sidra, Synchro, and Vissim or other simulation tools. Is the day of A through F done, and is it pass, fail? Priority rules, conflict areas, analysis is provided for left turn lane, and basically rounding numbers. I've dealt with that with parking generation. It really is not a happy thing to be going into areas of expertise that we don't know in our profession at 2 and 3 decimal points. And then finally, the dollar of effort to the return that you get in terms of calibration and amount of effort. There's a point at which you need to be able to estimate before you get in that it's just going to take too much time and is finding good enough at another analysis tool, another tool. These are all good topics. This is what we have conferences for. And you all have an email when you get home that outlines this meeting in Rapid City. We just got them out. I think I sent 6,000 emails out today. So you will all have a chance. Take a look at the technical program. We literally will allow you to build your own technical session. And this topic deserves a technical session. All you got to do is call me or Cheryl Lambrick in the Midwest, if anybody in the Midwest is listening in, and we'll build a technical topic around this kind of format. It doesn't have to be talking heads. It can be a round table. It can be an open discussion. It can be, hey, we did some stuff for 2 hours on the weekend in our spare time. We can do anything. And it's literally to advance this in our industry. And they brought up Nate Silver's book. If you haven't read it, it's really quite good. It's a long read. But at the end of the day, we can get a lot better in our industry. And this is the starting point of sessions just like this. So take a look at your email when you get home. You'll see all that stuff in there. So.
Okay, there's one thing Randy said that I have to bring up. So a lot of people worry about the calibration of the Vissim model is going to cost too much, or the traffic analysis. But when you're spending $1 billion for a project, maybe the part that you're cutting the money out shouldn't be on the traffic analysis.
Shouldn't be the traffic analysis.
Maybe you don't need as pretty of an overcrossing that's going to fade away in the future. But I'm not a bridge engineer. They might argue the other way. But yeah, that's
Are you going to be editing the YouTube out?
All right. Thank you, guys. I think we're going to dial off and stop the presentation.
Sounds good. Thanks.
Thanks, everybody.